All right, let's take some data and put it on a topographic map and use that data, specifically strikes and dips and lithology, to draw some contacts. So this is the first step in creating a geologic map. So if you look on the edges of most modern maps, you're going to see a series of digits that are not going to be the latitude and longitude. They're going to be either 6 or 7 digits, and those represent the what's called the UTM system. If you're not familiar with it, it's the Universal Transverse Mercator system, and that is a system broken down into meters that allows you to have a lot higher resolution when you're navigating than lat and long. Lat and long's not super useful for navigating, especially at the small scale. And so what I'm doing here is drawing in some blue lines that would connect my UTM grid in. So each one of these blocks is 1,000 meters, or a kilometer by a kilometer. And if I am using my GPS, I can just simply look at the digits and figure out exactly where I am and put my data on there. I'm just going to get my UTM grids all drawn in. I like to draw them in blue so that they really jump out and I can distinguish them from any other features or geology, which I'm going to draw in this case in black, but usually I would draw everything in pencil first, but you can't see that super well, so that's why we're going to draw everything in pen. I also always, when I'm drawing a map, I will draw a first draft, and if I make any errors, try to correct them on the fly and then create a nicer version at the end. I'm going to speed this up because this is, I'm sure, pretty boring, but I'm taking my time. I'm using my straight edge to make sure I like where my grids are, because if my grids are off, then my data points are going to be a little bit off too. On the map that you've been given for this mapping exercise, there are already grids on there, but it's important to at least know what to do if you don't have grid lines. But they're very important for getting the correct location onto a map. All right, now that I've got my grids, I'm going to switch over here in a minute to a black pen and start putting my data points on there. So remember, all of these values, they increase from the thousands position. So if you look in the bottom right corner, that value is 3763000. And so the 000 part is any number of meters further north than that line. And so I'm looking up to find my first data point. And my first data point is going to end up falling in this grid system right in there. And then I'm using my straight edge and then I've got to kind of measured out the angle here to draw the strike and dip symbol. That's the strike direction. I'll draw that in. I don't want it a massive symbol. I want it to be large enough to see and read, but I don't want it to overwhelm the whole page and just kind of swamp everything else. Now I'll put a little tick mark, that's the dip direction, and then I'll write the dip angle right there. And so that's my first data point. I'm going to look over by my second data point, find its location on the grid. There's a thing called a UTM grid reader, which you can set right on these little grids and find the exact spot. But I've got these marked on a second map, so I know they're in the right location. Right there, just write the strike. Make the strike line, put the dip symbol, and then write the dip direction, or dip angle down there. Now, between this next data point, once I finish writing that, the rock type changes. So they change from one limestone to a different type of limestone. And so I need to think about how to draw that contact in there. And the one reason I've kind of stopped is to make sure when I draw everything in here that I give myself enough space to draw in a contact where I can break up the two different units. So this next strike and dip, it's going to be in a different unit, so I've got to squeeze a line somewhere between those two data points. All right, so here's part of the trick. You want to make sure you're representing your data, and you want to make sure you're drawing it nice and neat, because it's all about communicating information. That is the only reason that we're drawing these maps. And so right in here, I'm going to draw this contact that separates the unit to the southeast, which is actually up the slope, from the unit to the northwest, which is also down the slope. And so I'm drawing that in, and right where I have a definable contact, I know the contact is right in there, I've drawn a solid line. And then once I get away from that, I'm going to start to put in some dash lines, but follow topography. All right, so here's the deal. these rocks are dipping. And the fact that they're dipping means that they're not going to necessarily follow topography easily like with flat-lying rocks. But in this case, the ridge is running northeast, southwest, parallel to the strike. And so if you think about tilting a book on its side and you had a contact would be the base of the book, the contact will run parallel with the ridge. All right, and so until I hit a major drainage or a major river that cuts through, the line is going to run parallel to the topography. And I've got another contact in here, so I'm going to draw that line, keep it solid where I know I have that contact, follow the contours. That doesn't mean the contact can't go up and down the topography, but it's going to do so very gently if the ridge is parallel with the strike. So I'll just dash these contacts on up towards the north and towards the east and keep this kind of following along the ridge down to the south, because I know the ridge parallels the strike of the rocks. Okay, I'm going to speed this up, but I'm just continuing on. I'm putting my strike and dip symbols in the location that the UTM grid tells me that those data spots came from, and where I see major changes in lithology, I'm drawing in contacts between the two to separate the two different rock types. Then I'm going to follow topography and best I can separate two different rock types with those contact lines. So you're trying to follow topography where you can. You're also wanting to try to kind of partition similar topographies on either side. So if one rock unit seems to have very flat rolling topography, you're going to want to draw the contact so that that all stays on one side. Okay, right in here is where what's called the rule of V's kicks into play. And that's where if you have a unit that strikes across a valley and the valley cuts through the rocks, the contact is going to V down into the valley. And you can see me starting to draw a few of these as the rock would be dipping towards the southeast, and then the contact between those two rocks has to V into that valley because it is a plane that is cutting down through the topography. And so the contact is lower in the valley in the dip direction. And so that's what those V's, they almost look like the way you would draw birds if you were doing like a fifth grade art project, you know, the little bird that you would paint on there. Kind of like that, but you're V'ing down. The V's point in the dip direction. And as I follow topography in my data, in this case, those contacts kind of wrap around. Put a few more data points on here, but I also can see a major age boundary right in here, so I'm drawing that in, and that has to be a fault. And I know that because the rocks to the southeast are Cambrian, and they're sitting on top of upper Paleozoic rocks, Silurian and younger. And so I know those rocks have to be thrust up and placed against these other rocks. I'm also going to start labeling things as I go, and that's really important so I make sure I remember what I'm doing. Remember I said I make one version and then I will go back and make a second version, and so if I mess something up, it's fine if I do it here. In fact, I would normally be drawing all this in pencil, but make your mistakes here, but make sure you're labeling as you go, and that'll make sure you don't get things out of order or in the wrong sequence. The other thing I am doing that you can't necessarily see because I was pausing it and pausing the video and working out to the side is I put all my symbols on a blank sheet of paper as I go. So anytime I use a new symbol, I put it on my symbology. It's really important to have an explanation for all maps. So that includes any symbol you use. The Dash lines are contacts that I'm, quote, inferring. Those are inferred contacts. The solid lines, those are very approximately located contacts, right? Really close. They're not inferred. I know the contact is in there. The strike and dip symbols, the fault symbol, any symbol you use needs to be on the explanation, even if you think it might be obvious. I need a second fault in here because some of these rocks and some of these contacts and topography are kind of cut by another ridge. And I know the lithologies are cut, so I'm missing strata. So I had to draw another fault in. All right, there's a big valley over here. You can see I'm making a very dramatic V cut right there as the dipping bed cuts down through the topography. That's a very strong usage of the rule of V's right there. But that's because the river is cutting through the rocks and then the plane is cutting down through, or the plane is being exposed further down in the stream. So you have to draw those rule of V's. I'm going to speed this up, but I'm just going to continue to fill in the map with the data I have, drawing in lines. I started kind of in a central area where I had some data that I really thought I understood. I had a lot of closely spaced data, and then I built the stratigraphy towards the southeast, which would be going, quote, up section. Now I'm going to work back the other way. So I'm kind of going down section for the most part. I'm just going to keep filling in data. When I've got the data, I can draw it in, draw in lines where I see the major lithologic contacts, and ultimately I'll get this whole map filled in pretty fast. I've got another data point up here that's a little bit off, and I see some of these ridges running into other ridges, and that usually only happens where you have a fault. So I know I have Pennsylvanian stratigraphy up here in contact with Ordovician Cambrian stratigraphy in the middle, and so I've got to do something with that, which means I need to put a fault in there. So I'll kind of sketch this in, make sure everything works, make sure all the units are still there unless they're up against that fault. If a unit is touching a fault, it can be cut out, or you can be missing stratigraphy beneath it. So I know I need another thrust fault to put the older rocks up above, structurally, the upper Paleozoic rocks, almost exactly like we have in the southeast side there. But I'll just draw these in, make sure my data points are all there. I also have a dip change, if you look right there. I drew one of those dips. It's dipping towards the northwest up in that corner, whereas everything else is dipping towards the southeast. So not only do I have missing rocks, but I have a dip change that tells me there has to be a fault on that northwest side. And so I'm just making sure I sketched everything in. And when I get done, this sketch map I wouldn't color in, but I would make sure I like everything. If I made some errors, I would correct those. And then I would take that map and redraft it. So the easiest way to do that, if you have a light table, you can take the light table, put the fresh map on top. You can also tape the paper up against a window if you don't have access to a light table. And so that way your final map, I again would do it in pencil. So you're tracing, your initial map is done in pencil. I like to take a Sharpie and go over it when I finally get committed to what I've drawn. And then I'll take that, put it on the light table, and put a fresh map on top, and then trace that onto the top in pencil, and then ink it again. So right, pencil, then ink, and then copy it up in pencil, and then ink it again. And then the final component here, I'm drawing in, I see those rocks have to be kind of tilted like that, so there needs to be a fold in there, so I'm going to label it. That's the symbol for a syncline, so drawing that in. But all I gotta do now is color and I'm good to go.